Okay, so currently the battery is off. So when I turn it on, we have the electrons being repelled from the negative side of the battery up here and then gradually building up on here. And the equal and opposite charge will build up on the other plate. Now, eventually it's going to get harder and harder to put these electrons onto that plate because the first few electrons that we put on there are going to repel newer electrons. And so the current, what this doesn't really show you quite so easily, we could do with a graph to show it. The current will actually get slower as time goes on. Eventually, the current goes to zero because the voltage across these plates, is going to be equal to the voltage across this. Now, I can make the amount of charge per voltage that I can gather onto these capacitor is known as the capacitance. So, how much charge I can put onto a capacitor is the capacitance, but it's the charge per voltage. Okay. Now I can change if I were to make this capacitor, the area of the capacitor larger, we're going to be able to put more electrons on there. And so a larger area will increase the capacitance. I will be able to put more electrons at the same voltage. So, well, what about the separation? The separation often confuses people. They think, how is the separation going to really make a difference? If I were to make the positive plate go closer to the negative plate, it actually increases the capacitance. So if I move it further away, it decreases the capacitance. If I move it closer, it increases the capacitance. Why does the closing and why does the gap between the two plates increase or decrease the capacitance? It's because that as extra electrons coming towards a negative plate, they are on the one hand being repelled by the plate they're trying to get onto, but they're also being attracted by the plate behind that plate. They're being attracted by that positive plate. So if I were to close that gap, the positive plate there is going to encourage more newer electrons to gather onto that negative plate. Now, the electrons never jump that gap unless something goes wrong, but um, basically there is still going to be an attractive force from the other plate. So over here, I'm trying to put electrons there, and this positive plate is attracting the electrons towards it. And so as I bring the positive plate closer, more electrons are able to gather onto that. Eventually, now a large area and a small gap will give the maximum capacitance. And then when I open that switch there, now we have a load of charge built up. As soon as I close that switch, the electrons are going to be repelled and then make a circuit through there anti-clockwise, and they're going to have a very high current to start off with as they get pushed away from one another, and then gradually the plates are going to become less and less charged, and so the current will reduce. And the effect that you'll see is the light bulb will be really bright and gradually get dimmer and then go off. Very, very bright. You can see the charges are dissipating, and eventually it will go off. So the electrons are still repelling the other electrons, but with less and less force, and so the current reduces until eventually the charges have equalized on either plate. It's important to realize that the charges equalize by going around the circuit, not by jumping the gap. They don't jump the gap, they go around the circuit, and that's why they only were able to discharge once I close that switch. Okay? All right, I'll stop there.